Okay, 3.4 is called graphing linear equations in standard form. And first we're going to look at some horizontal and vertical lines. So you really need to know what horizontal and vertical means first off. So I think of the horizon when I go to the beach. You look out at the horizon, and the horizon is a flat line like that. And a vertical line would be like this. So if you're trying to climb a vertical cliff, that's a cliff that goes straight up and down. Okay. All right. So equations for horizontal lines are always going to take the form y equals b. This is a b, not a 6. Okay. So y equals some number. So that number can be anything. It could be y equals 7. We could have y equals 2.3, etc. Right. So it's going to be y equals something. A vertical line is going to have the form x equals something, and I'll say x equals a here. So this could be x equals -10 or x equals 14 and so forth. Okay. Since the horizontal lines have the form y equals something, that means all of the y's in at any point on that line are going to be the same. And with the vertical lines, since they're x equals lines, all the x's are going to be the same. Okay, and that's a nice way to memorize the difference between these types of equations. So, you know, some of these are going to be vertical and some are horizontal. And I know we have it right there as a guide, but if you're on a test and you have to graph this, a lot of times I'll see people graph x equals 2 like this. But this would actually be y equals 2. X equals 2 is going to look like this, okay? So if you're not sure and you forget, just think of some different ordered pairs where the x is 2. So I'm going to put in 2 for my x on a couple of these, and I can put anything I want in for y, it doesn't matter. So I'll go 0, 1, 2. And if I plot those points, so those all have an x coordinate of 2, I've got 2, 0, 2, 1, 2, 2, and pretty quickly I can see that this is going to be a vertical line. Okay, so that's a nice way to double check that to make sure that you get it going the right way. Okay, and we can do the same kind of thing here. I'm just going to make up some ordered pairs where the y is 4, since this is going to be the line y equals 4. And I can put whatever I want for x's. I'll just put 0, 1, 2. So let's see, 0, 4 would be here, 1, 4 is here, 2, 4, 2 to the right, 4 up, and pretty soon I can see, okay, this is going to be a horizontal line. Okay, and if you just remember which is horizontal and which is vertical, that works too, but you can always check your work. So x equals -3, I'm going to choose all of the places that have an x coordinate of -3. And I'll just put 0, 1, 2 for the y's here. Doesn't matter what the y's is. So 3 to the left, 0 up, 3 to the left, 1 up. And then I can see, okay, this is a vertical line. Okay? And y equals -1. I'm thinking, okay, 0, -1, 1, -1, 2, -1. Those all have y coordinates of -1. Okay? And that's graphing horizontal and vertical lines. Okay, on the next page, let's look at some equations in standard form. Whoops. So in standard form, a standard form equation is going to be look like this. So it's going to have the x term first, then the y term, then the equal sign, and then what's called the constant. So a, b, and c here are going to be any numbers. Okay. So I've got my x term, my y term. My constant is just the number that's not attached to a variable. Okay, so there's two examples of equations in standard form. And the way we're going to graph these for the time being is by using x and y intercepts. Okay, so an x-intercept is where my line is going to cross the x-axis, and the y-intercept is where it's going to cross the y-axis. So to find these intercepts, in both cases, we're going to be plugging zeros into the equation. You just have to know where to plug in the zero. So to find the x-intercept, you're going to plug in 0 for y, because if I'm looking for any point on the x-axis, is going to have a y coordinate of 0, right? I got 1, 0, 2, 0, 3, 0, 4, 0. So that means the x-intercept has to have a y coordinate of 0. So I'm going to plug in 0 for y and then solve for x. Okay? And when I'm finding the y-intercept, I plug in 0 for x and solve for y, because the y-intercept would have an x-coordinate of 0. Okay? And if you forget which one is which, you can just plug in a 0 somewhere and see what's left. So, so let's say I have this equation here, and I'm looking for an intercept, and I forget where to plug in a 0. I just choose one of the variables. I'll plug a 0 in for the y first. Like this. And then when you look at the variable that's left, there's only an x left, which means I'm going to be solving for x, and that means this is going to be the x-intercept. Okay? So you can always figure out which of the two it is that way. So 3 times 0 is 0. That means I'm just left with 2x equals 6. And now to solve for x, I'm going to divide by 2. And that means x equals 3. Okay? That's my x-intercept. So you could say that's the point 3, 0, or you can just say the x-coordinate where it crosses the axis. So 3 to the right on the x-axis, that's where my line crosses the x-axis. So I've got that point. If I just get one more point on the y-axis, then I can just connect the dots and draw in my line. So let's find the y-intercept. That means I'm plugging in 0 for x. Okay, 2 times 0 is 0, so now I have 3y equals 6, and I'll divide by 3 to isolate the y, and y equals 2. So there's my y-intercept, so that means right there. Okay, and now all I have to do is connect the dots. Sometimes I see people do this, but that's just a line segment. We're graphing a line, right? So I want the line to continue in both directions infinitely. So something like that, okay? All right, let's try another. I'm going to find the x-intercept by plugging in 0 for y. Okay, and that's just a 0, so I have 3x equals 3. Divide by 3, and I get x equals 1. Okay, so let me put that in the graph there. That's where it crosses the x-axis. And then my y-intercept, I'll plug in 0 for x. Okay, 3 times 0 is 0, so that leaves me with just y equals 3. And that means here is my y-intercept. And then I connect the dots and make a line that goes through both of those 2 points. Okay, all right. On the last page, we're going to look at a word problem. Okay, so got this big graph here. So, all right, this says Bilbo is going to rent tables for his 71st birthday party. He needs to be able to seat 180 hobbits. Small tables seat 4 people, and large tables seat 6 people. Okay, so X is going to be the number of small tables. So that's my small tables. Makes sense. Get 4 people per small table. All right. And then it says that Y is the large tables. And that makes sense because you get 6 people per large table. So when I 4x would give me the number of people that can sit at the small table. 6y would give me the number of people at the large table. So together I want those to add up to 180. Okay, so this equation is going to model that situation. Okay, so what I'm going to do is graph the line represented by this equation. Okay, so I'm going to find a couple of points first so that I can connect the dots, and the 2 points I'm going to use are the x and y intercepts. Okay, so I'm going to graph this using the x and y intercept. So let me zoom out a little bit. Down here, let's find our x-intercept by plugging in 0 for y. Okay, so now I have 4x equals 180. And to solve for x, I'm going to divide by 4. And 180 divided by 4 is 45. Okay, so that should be my x-intercept. So let's go ahead and on the x-axis, which is the number of small tables, it says these are my x's here. Let me zoom in. We only really need the equation up there. All right, so 45, hey, that's way over at the end, right there at 45, okay? And then let's find the y-intercept. All right, and I'm going to plug in 0 for x into the original equation. Okay, so 0 plus 6y, so I get 6y equals 180. And when I divide by 6 here, I'm going to get 30. Okay, yeah. Y is 30. So my y-intercept, that's at the very top of the provided graph here. Okay. So now I just need to connect the dots. Just to make this as neat as I possibly can, I'm going to use a ruler. All right, let's see. Something like this. Okay. Okay, so there's my line. It doesn't go on forever because if I went to the left here, then I'd have a negative number of small tables. And if I went down here, I'd have a negative number of large tables. We can't have negative numbers of tables. So we're only doing using the top right quadrant because these are all positive numbers. Okay. So we could do this. If you look at the two intercepts, this is 45. This would be the point 45, 0, right? So this means, remember, our x's were the small tables, and then the y's were the large tables. So we could do this with 45 small tables and 0 large tables. Or if we go up here and we look at those coordinates and we interpret those, we could do this with 0 small tables and 30 large tables. But you could also have lots of different combinations where you have some small tables and some large tables. So those other points are going to be xy pairs. Okay, so it asks us for possible combinations. So we've got 2 of them already. I could say 0 small and 30 large. That's from right there. Or I could do 45 small and 0 large. But we can use any of the points on this graph as well. So it's a little bit hard to see, but I'm just looking for points that appear that they're right on the grid. So I don't want to use fractions because I can't use parts of tables, right? I'm going to use whole tables. So it looks to me like that would be a pair. Okay, so I'll use that one as another pair. So let's think about that. It looks like it's 42, 2. If you look at the coordinates there, it's 42 to the right, 2 up. So that means I could use 42 small tables and 2 large tables. Okay, and if we look for another pair, maybe I'll do one near the other corner. It asks for 4 possible combinations. I got 3 of them. So it looks to me like this point is right on the grid. And the neater you are with your graph, the easier it is to tell what points are exactly on the grid. This would be the point, let's see, this would be 328. So that would mean 3 small tables, 28 large tables. Okay, and those are just 4 possible combinations. There's lots of them. Any point on this line would work, but you want ones that use integers, not fractions or decimals. Okay, all right, that's the end of the lesson, and I will see you next time.